We on the organizing committee have some hopes for you today. We hope that you enjoy learning new things and about new tools from the talks, that you meet great folks, maybe even the person next to you right now, and say hi and meet new people, and that you've come away empowered and inspired with new tools and new ideas. And so we hope you have a great time at the rest of the conference. And without further ado, I'm going to introduce our first keynote speaker. Andrea Trevino leads the data team for League of Legends at Riot Games, which is one of the most played games in the world. Before joining Riot, she was the director of data science for datascience.com, and she brings a perspective from her backgrounds in healthcare, ad tech, digital media, e-commerce, and her PhD work in electrical and computer engineering from the University of Illinois at Urbana-Champaign, and as well as her work at research work at the MIT Lincoln Laboratory, the MIT Institute for Learning and Memory, and the Boys Town National Research Hospital. So please join me in welcoming Andrea.
All right, good morning, everyone. Thank you for that wonderful introduction. I would also like to thank the organizers for inviting me to be here today and putting together this wonderful conference. So without further ado, I'll go ahead and get started. I've already gotten a great introduction, so I don't need to go over it again. But yeah, I lead the team for League of Legends at Riot Games. I wanted to start the talk with one of the questions that I get most often, which is, how did you get into big data and data science personally? And what I wanted to get across this morning was that there is no one path. Every single person has a completely different path, and this is just my path into that process. And the path that I followed is that I didn't start in big data and data analytics. What I started with was in the 90s, I thought robots, video games, and coding was cool, and I went with that. So back then, I was more interested in coding and understanding circuits and understanding the systems that worked in place. Back then, data science wasn't really well known in pop culture, but there were elements of it starting to bleed into the public consciousness, all the way back as the Terminator, which was already talking about his neural net processing system. When I went into research, I took a wavy path in terms of my route to ultimate data science. I started in high-energy physics. Then I went into wireless communications, a brief stint in brain-machine interfaces, then actually modeling how neural processes would respond, and finally perception and automatic speech recognition. While I was going through this path, as was mentioned before, the business and industry world was starting to discover more and more about data. So in the early 2000s, everyone in industry realized that collecting big data was absolutely vital to understanding their business and their success. And then around the year 2008 is when data science was ultimately coined and started to become a thing where industry realized that they could take all of this data that they had aggregated, start adding in some algorithms that had been existing for years and years before in research and science, and creating this new field where you combine business understanding and data modeling in order to build a competitive advantage. So now where we're at is that data science is a key part of every single industry. You'll see data science in public policy, in retail, in automotive, in the entertainment industry. We have Netflix here in town. They have a giant data science department. You see it in healthcare, in transportation, and the one that I'm involved in right now is data science and gaming. So I'm at Riot Games. To give a quick introduction to Riot Games, the company, we're located here in Los Angeles. We are the developer and publisher of the game League of Legends, and one of our key cultural values is putting the player experience first. So the game itself was launched in 2009, which is a long time ago in the data world. It's a team-oriented player versus player game where you play as a team of 5 against another team of 5. We have over 100 champions that a player can choose from when they actually jump in and decide to join the game. And we're set in a modern fantasy world. So in the splash art here, you'll see there's a scarecrow, there's like a little girl with an angry teddy bear, a mage. It's just a whole giant world of possibilities. I wanted to start by introducing the actual game itself so that you can start thinking about the complexity of the space and what it would do in terms of data science problems. So this is the actual map that you play this type of game on. The way that it works is it's split into two halves. You have a red half and a blue half. You try to control the world and have 5 people on your team to help you. There's 3 lanes through which players will play. You can think of this really like a physical sports game. And actually, League of Legends was one of the first games that introduced and popularized esports as a category. So then you have players take different positions within those different lanes. So these are 4 of the 5 champions that you would play, and then you have 1 more to roam. So these are the fundamental rules of the game. If you think of like football or basketball, these are the different positions that you can play. And understanding how you would approach data science problems, in order to understand that well, you need to think about actually understanding the game itself. There's a number of objectives you can take on the board, and then you win by seizing your opponent's objective. So that is the high-level picture of the game. But let's start to think about this as data practitioners. So what kinds of problems are being introduced within this ecosystem? Well, I mentioned that a player has to pick one individual champion. We actually have over 140 champions that a player can pick from, and each individual one has a completely different set of powers that are available to the player. When the person chooses this individual champion, they will be playing with them for 20 to 50 minutes solid. So going through all 140 plus would be a major time investment for an individual player. Another source of complexity is that we have major releases for the game internationally every 2 weeks. And what I mean by major releases is that we can release content. We might release new champions. So if you think about this in terms of sports, it's like introducing a new type of player to the field and seeing what happens to the game. We introduce new maps. We have events. These are major changes to what is possible within the space of the game, and these patches and releases have been happening every 2 weeks, almost since 2009 itself. We also release completely different maps, so it's like you're changing the field or the court in which the play is happening. And finally, we have a fully international game. We are in many, many, many different regions, meaning we are adding the complexity of culture and different languages for any of our data science problems that we would be solving. In addition, each region, like Europe, North America, Latin America, Korea, is on a completely different set of servers, which means that the community and the style of play develops independently within those individual regions. And then there's the numbers themselves in terms of the players. So we have over 100 million monthly active players, over 500 billion data points per day, and petabytes of data. So for those of you who are data practitioners, you can start to see what all of this intricacy and complexity can present in terms of not just things that would be difficult to solve, but they're really giant opportunity space for the world of data science. So how do we make decisions within a world of this scale and this amount of complexity? The first and fundamental rule at Riot Games is to aspire to be the most player-focused game company in the world. And this may seem like a simple statement, but it is absolutely crucial to every single decision that we make, and it really helps to simplify how you're going to be making decisions in terms of the product and the processes that you follow. You always go back to the fundamental of, is this something that's going to make the game more fun, more fair, that's going to bring value to the player? When you have to think in a way that focuses on the individual, the way that you decide to do data science becomes more clear. When you decide to build a model, you can choose to aggregate it at different levels. You could aggregate to the region. You could aggregate by champion choice. You could aggregate by map. But if you want to truly focus on the individual player and make sure that each individual's information is being represented and modeled, you need to build your models at the very granular player level. It's the only way that we've found to account for all the variability and complexity within the system. There's a couple of other key points that I want to highlight in terms of decision making. So the first is building individual models to suit the individual needs. The second is to recognize when you have separate systems. So when I mentioned before, we have different regions under which completely different styles of play have developed. So the Korean player base might be very different from the North American player base. When you have variability within a system in a machine learning model or a data science model, people will often add this as a different degree of freedom or feature within the model. But it's very important to recognize when the equation itself might be completely different for your different systems. And in those cases, you need to build completely separate models for that use case. One of the key things in all of industry's use cases is segmentation and audience understanding. Since we have a system that is changing rapidly at a minimum of every 2 weeks, you need an approach that's dynamic and changing over time in order to be able to model and monitor how those changes are happening over time. And the last point I wanted to highlight is that models need to function within this constantly changing space. This seems kind of obvious, but it means that you need to build a model that is extremely robust. So you either need something that does not vary underneath all of these changing degrees of freedom, or you need something that is going to be able to retrain fast enough and adapt with the other changes. In terms of the types of work that we do at Riot Games, they fall into 3 buckets. The first would be deduction. This is where you're solving problems of identification. So is this someone who's trying to bring fraud or hacking into the game? Is this someone who is of this particular rank? Is this someone who would like to play this champion? Being able to identify the differences within the system. It also allows you to explain the systems and suggest action. The second type of bucket would be under personalization. When you have all of this variability to present to players, each individual has different kinds of experiences that they want to have, and you can use automated machine learning techniques in order to provide an environment that is more personalized. And the last is optimization. Since we have a system where you have players playing against other players, you have lag time, everything is running live, you need to think about how to optimize those systems so that you can present the best experience that you can. Finally, I wanted to talk a little bit about the data science skills that come into play at Riot Games. This is not exhaustive, and each individual person doesn't need to know all of these. But you do need to build a team that spans across this range of knowledge so that you can solve the huge range of problems that are going to be presented to you on a day-to-day basis. In terms of our stack, we use a pretty common stack. We use Python, of course, every single day, or PySpark. We also use R for some of our modeling. We work on the Databricks platform. Riot Games is an AWS or Amazon Web Services shop. And when we're doing business visualizations and business analytics, we work with Tableau. So now I'll jump into the fun stuff, which is some of the actual use cases that we've done at Riot Games. Again, this is not an exhaustive list. There is so much opportunity in this space. I'm not even going to mention esports, InfoSec, content. None of that is going to be necessarily what I'm going to be talking about, but there are just massive spaces for this. So the first and a fundamental one is understanding positional play. So this is another view of that map that I showed before, which has 1 lane across the middle and 2 lanes across the side on the top and on the bottom. When a player decides to join a game, they join a system where they're looking for a team to be built for them. So in this case, maybe someone said that they wanted to play the middle position. We will automatically match them with the rest of their team so that they find a complete team composition. When you do that, you need that assignment to be done accurately and fast. People don't want to wait longer than 15, 30 seconds to get their team assignment so that they can jump in and actually start playing the game. Another point is we can automatically detect how positions are being used within the game. So we can see if we assign someone a particular position, do they follow through with using that position? How do they play with it within the game? Do they stay within their lane? Do they move around? What are the mechanics of the game and how are they changing? This helps us understand how our systems are actually interacting and determining play. It allows us to track changes over time and understand one of our key concepts, which is the meta, or the game mechanics that one would use. Another point, and this one might have popped into your head as an obvious one, which is champion recommendations. When you have so many to pick from, and each one is an individual different playstyle, recommendations come to mind. So we have a champion recommendation engine that allows us to understand how playstyles evolve and how they change over time. We can see what champions are grouped together and which ones are unique playstyles. We use it to better recommend some champions for the new player experience. So when you jump in and you start doing a tutorial, there's particular ones that we might recommend. It also allows us to build recommendations into our store. And we use years and years of new player data in order to model the cold start problem and use tagging for new content or champion cold starts. Ultimately, it allows us to build and recommend content to players that they're going to get extremely excited about. So I didn't make this GIF. We found it on Reddit. But so this is when we give, a couple of times a year, we give our players personalized recommendations and discount them. And they get really excited about that if we give them a good match. So finally, one of the fundamental use cases that you see across the industry is player segmentation. And we have a lot of different audience types within our game. The biggest and most well-known is being part of our ranked system. This is where you grow in your champion mastery and competitively play against other high mastery players. So in this case, you can grow from bronze to silver to gold and ultimately to challenger. And I've played against some of the players that are up at the very top, and they are superhumans. Another way that you can play is socially. You just want to come in, hang out with your friends, spend some time. It's a completely different experience. And then there's players that kind of make their own game within the game. There's enough flexibility for that variability to be within there. But even though that is a smaller player base, we still need to make sure that we're serving that very important player base that we have. Within all of these use cases, the fundamental rules of modeling still apply. So you still have to be very careful and find a lot of information within your feature engineering so that you can accurately represent all of the variability within your data. You need to account for bias and normalization, and there will always be missing data. You need to control for confounds. If in a particular major release we have new content, a couple of countries go on vacation, maybe we introduce a new map, and we throw in a brand new champion in one release. All of a sudden you have all of these different confounds within the system, but you still need to be able to model them and answer questions about them. There's going to be outliers, not just in terms of people who are trying strange things or scripting, but you'll also have outliers in terms of experience, and you need to understand what's going there. There's always a danger for overfitting, particularly when you have data at this scale. And finally, the most important thing, I think, when you're applying data science to business use cases is adding in subject matter needs or considerations. And in this case, it means that the player experience is fair and fun. So when you're building a model for gaming, you might not want to use the most optimal or the most accurate model. You would want the model that provides the best experience to the entire audience overall. So how do you build a team that actually solves all of these different problems? You need a lot of different roles. You don't just have data scientists, or you don't just have data engineers. So you need a balanced team where you have data engineers and architects that are building the fundamental infrastructure and allowing you to create solutions that are high speed and high scale. You have data scientists building the algorithms and actually designing the approach for machine learning and AI. You have analysts and a strategy team that interface with your business users and answer the broad questions. And finally, you have data managers that make sure that all of this is actually happening, get the resources for the team, and figure out the best product direction. There's also a couple of ways that you can distribute the team. A lot of people have asked me about embedded versus centralized teams. When you have an embedded model, you take a data professional and you put them in with a team that might not be the same skill set as them. So this might be engineering or product, or in our case, game design. And they have completely different skill sets that can complement each other, but in a sense, they're coming in as a representative of the group. Another way that you can group your data professionals is to centralize them and have them all together in one group and then operate more like a consulting model. There's a couple of different things that are modified when you use these two different types of team structures, mainly your product, your communication, and your delivery. And what I've found has happened is when you have a centralized team, it allows you to build a deeper solution because you have a lot of different professionals collaborating with each other. And it also allows you to prioritize across the entire org and find where the best opportunities might be. In terms of communication, it is absolutely the difference between success and failure. Even though we are working in a technical space, because we are providing solutions that plug into a lot of different systems, communication is absolutely key. And finally, since delivery is going to be interfacing with other external teams, there has to be very careful planning. Another way is the embedded model, where everyone is directly with the team that they're going to be working with. Since you might have fewer data scientists, or you have limited or siloed expertises, you solve what you can and provide value where it's needed in that particular team. It means you'll always have a resource available, but you might not be prioritizing across the entire org. But it does mean that communication is easy, and it does mean that delivery can be more flexible. Ultimately, I say build what you need. These needs change over time, and at Riot, we use a mix. There's a big central team that we use to meet the large needs of League of Legends, but then we'll have particular embedded data scientists where we know there is going to be a data need at all times. So finally, what are some of the things that I'm looking to build on at Riot Games? It's really three big categories. The first is building more on the personalized experience. There's so much that we can build in terms of giving players the experience that they're looking for and making it specifically catered to their particular needs and wants. The second is full modeling coverage of all of our dynamic systems. This is just my big picture thought of what all industry needs for any of their business processes, which is a model that explains the system and helps you make better decisions about those systems. And for anyone else who's in the room and is in industry, you know that even if you've been at a company or your company has been around for a long time, you always need more investments in speed and scale under the hood and building infrastructure that can support all of your different use cases. So that's it. Thank you very much. And I think I have a little bit of time for questions. Feel free to come and talk to me afterwards. We're hiring data scientists, data engineers, and data analysts. And thank you very much. There's a couple. I don't know. I thought there was going to be a mic floating around.
Hey.
Hey.
Okay. Yeah, thank you. I had a question. You said that you try to optimize for user experience, and that would seem kind of hard to quantify. So I was wondering what sort of metrics you use instead of, say, accuracy in your models.
Yeah, so it really is about the players' engagement with the features that we put out. So you can do simple statistical testing to see if someone actually engages with the thing that you're doing, or if they stick around more and like it. So churn, engagement, retention are the basic KPIs that you would look at.
At one of the points, you mentioned that some of the targets for your models is building experience that's fun and fair for the players.
Yes.
How do you define fair?
Yeah, so this is something that a lot of different games build into their matchmaking, and it's having a set balance so that the teams have about an equal win prediction when you create a match. So you're trying to balance your matchmaking so that they have a balanced game, one that's fair, where one isn't very, very slated to win out over the other one and they would just stomp them. Does that make sense? Yeah.
Good morning.
Morning.
How do you handle the ownership between the people who own the data, which I assume is a very technical thing, and they have their own area of expertise, and then you build your models, and you have to pass your models into production. So what's that whole pipeline look like?
Yeah, so there's a lot of communication there. We actually start with our game designers and product and try to see what experiences and products they're building, what features are they going to be releasing, and where are the opportunities for data. We know our data pretty well, so we can start to work with them collaboratively and understand where we would fit into that space. Once that we think there's a good enough fit, we decide to make an investment into the space and plan out to see if we'll make it in time for the release. A lot of our data scientists are essentially also engineers in that they can build some of the integrations into the systems. So then we just do a project plan, just like you would for any other software team, and build together so that we can get it out into deployment. The deployments vary depending on the speed and the type of deployment that you need. So you might build it straight into the software, or you might have something offline that's running that just gives better recommendations at some point.
So you mentioned about having the approach between the embedded and centralized for data scientists. And you also mentioned about the importance of communications. Can you highlight what is the effective way to communicate within the team?
Yeah, I think there's a lot of communication that's still growing in the industry in terms of what value data science brings, since it is a new area for a lot of industries. So people may be unfamiliar with what the particular use cases might be and why things that they've done in the past might not be, why can't they just keep doing the things the same way that they've been doing them in the past? So one example is customer segmentation. That's been around forever. Why would you do it using a machine learning technique? So you need to be able to explain the value. You also need communication just in terms of project planning. So you can't work in a silo. You must communicate what you're doing, why are you doing it, and since it is partially research, why it's going to take a time investment.
Hi.
Hi.
How do you version your models and your data? Having so much data, so many models, so many iterations on the models.
Yeah, we version using standard version control like Git for our models. And then with our data, we have snapshots, but that's something we're building a more rigorous ecosystem around.
A lot of what you've described today seems to be kind of after product release, but is your team involved in like A/B testing and doing stuff in the lead up to new features, especially not just in like marketing and sales, but also in game features?
Yeah, we have two teams at Riot Games. We have data and insights. The insights team is full of researchers and business analysts. that do more of the A/B testing or the examination of historical data. And then the research team works with surveys. They'll bring people in to play test. They'll actually ask people, do you like this? How do you feel about this? That kind of thing.
Hi, over here, sorry. So you handle a massive amount of data every day. Have you ever run into any issue in terms of data integrity or quality? If you do, how do you solve them, like the missing data you were mentioning?
Yeah, if anyone in industry hasn't run into issues with data quality, I would love to talk to them. Yeah, we do have issues with data quality. Things can drop out. The pipelines can suddenly get stuck or jammed in a way. This is where our data engineers are absolutely key. They put automated testing, monitoring, checks into the system so that we always know the quality of the data as it's coming through. And it also means that we have to be very careful at large scale to try to not miss anything, because every individual person needs to get a good representation of their outcome. When we give those personalized offers, if they don't match the champions that a player usually plays, we will find out. So data quality is a massive concern, but also investment for us. That's a question right there.
Hi, Andrea.
Hey.
Thanks for the talk. This was great. Can you give us a little bit of advice? Like, it sounded like y'all are dealing with a ton of models, and the first thing I asked myself was, how do you lower the cost or maintain a cost for training models that, if they're user specific, you had millions of models potentially?
Yeah.
Also, where are you storing them? How are you storing them? Like, at what point do you make sure that you can create these models in a cost-effective way and store them in a cost-effective way?
So we actually don't have millions of models. We just have a lot of features in the models, which helps. In terms of the completely different systems, I would say the biggest ones are region to region. But we don't have a situation where we're building millions of models, not yet.
Hi, just a couple of questions.
Mm-hmm.
First, with the amount of data that you have, how do you go about pulling it in a fashion that doesn't take a long time to just wait for?
Yeah.
And secondly, how do you? Sorry, I guess that's that one question.
Go ahead. But yeah, in terms of pulling just massive data, it's good fundamentals. So being good at knowing what you're supposed to do in terms of well-written SQL queries. We use Spark just across the board in terms of doing aggregations. We also have some of our engineers that work with Scala. So leveraging some of those technologies and grabbing subsamples as you explore the data so that you can start to draw conclusions before you decide to go all in and do a massive data pull.
Yeah, that was actually going to be my second question. Is are you going to sample that data just after collecting
Yeah.
it, or do you just brute force it?
You sample as you explore and build, and then maybe you'll build something that covers all of the data for your final productionalization, and that's where the architecture and the parallelization of your build really matters.
Any more questions?
Nice. All right, thank you.